Mechanical forces are potent regulators of cellular structures and functions in health and disease fields. Cells experience several mechanical forces such as pressure, created by the hydrostatic forces of blood within the blood vessel, circumferential stretch generated by cardiac pulsation, and shear stress, the dragging frictional force created by blood flow or any friction of a moving fluid onto a surface. Of these forces, shear stress is particularly important in microfluidics, as it stimulates the release of the soactive substances and changes gene expression, cell metabolism, and cell morphology and arrangement. Reproducing the shear stress in vitro is a key element for cell culture and organ-on-a-chip studies. It enables a better mimicking of the in vivo environment. Our shear stress calculator helps determine experimental parameters by predicting the shear stress level induced by a setup and an application. Users can also design experimental setup parameters based on a specific shear stress value. Here is a quick tutorial of how to use this tool. In the first field, one can enter the pressure or flow rate parameter with the referent unit of their choice. Unit conversion is directly applied when switching between units of the same parameter. In order to produce a certain level of shear stress, one can also input this value to get information about flow rate or pressure to apply in the system. One can choose between preset fluid properties or customized properties by inputting the required dynamic viscosity and density values. Negligible or not, the tubing resistance of the system can be calculated by inputting the inner diameter and the length of the fluidic path. The last field gets information from the used chip. Preset dimensions are available among our microfluidic chip list, though the user can precisely input the dimensions of a custom chip according to the chosen channel's cross-section geometry. Let's consider a basic setup including one Fluigent 1-bar pressure controller, associated flow unit for direct flow control, and a 15 ml reservoir filled with water at 20 degrees centigrade, connected to a single-channel chip, such as the B-flow chip for cell culture. According to our physical setup, the input parameters will be as followed: pressure 200 bar, fluid properties, water at 20 degrees centigrade, tubing dimensions, 20 centimeters with a 300 μm inner diameter. Chip geometry, B-flow chip. After computing the inputs, the user instantly gets results and information about shear stress, flow rate, pressure, Reynolds number, and velocity. Along with the results, products that match user requirements are recommended to optimally conduct the experiment. Here, a Fluigent 345 bar would work best.